Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the concept of the switching mode power supply, that means the SMPS. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the concept of the UPS, that means uninterruptible power supply. Let's start our today's topic. What is an UPS? UPS is acronym of uninterruptible power supply. It is an electronic device which is used to supply power to other devices such as computer, telecommunication equipment, etc. in case of power outage or power failure. That means when the power is not available or the power is disconnected, then the UPS provides the power immediately, and the whatever the task we perform on our PC or on our gadget will not be shut down. Okay. In normal operation, it draws current from AC mains, and during power outage, it draws current from its backup source. Okay, the concept is very simple that when the power is available, there is some backup system, that means some batteries or flywheels which stores the electrical energy, and when the power outage or the power failure occurs, then these batteries supplies immediately the power towards the load. Okay, this is the basic concept of the UPS. Now let's see the types of UPS. There are mainly three types of UPS available, and these are offline UPS or standby UPS, interactive UPS, and online UPS. Let's see details about one by one. First one is, what is offline UPS? The offline UPS is a type of UPS that directly supplies the power to the AC load from the AC mains in normal operation and uses an inverter to power the AC load from the DC battery. That means in normal operation, the offline UPS uses or offline UPS directly supplies the power towards the load from the AC mains. Here, in normal condition, the AC mains charges the batteries, and when the power failure occurs, then this battery provides power towards the load. Okay, this is the basic concept of the offline UPS. Since there are two separate lines of supplies, the output supply must be switched between the two sources. The switching speed of offline UPS is around 5 milliseconds, which is enough to keep computer from the shutting down, but not fast enough to keep smooth operation of sensitive equipments in hospital. That means in offline UPS we require a switch, and when the power failure occurs, then within 5 milliseconds the switch can provide the power through the backup device. The 5 millisecond time is enough to stop the computer from shutting down, but in the some instruments in hospitals are not suitable or are not sustainable for 5 millisecond delay also. Okay, hence this is not preferred in practically. Let's see the operation of the offline UPS in the two modes, in normal operation and in power failure mode. During normal operation, the power from AC mains is directly supplied to the output through a static transfer switch. That means during the normal operation, this is the AC mains, and the power is directly given to the AC load through this static transfer switch. Okay. At the same time, the AC is converted into DC using a rectifier to charge the battery using a charge controller. That means when the AC mains drives the AC load through the static transfer switch, at the same time this AC mains is used to charge the batteries, and this charging of the battery happens through the rectifier, filter and the charge controller blocks. We know that the rectifier converts AC into DC. This DC is filtered in this filter block, and through charge controller the battery is charged. Okay. But unlike online UPS, the inverter does not draw the current from the battery until the primary supply AC mains interrupted. That means in this type of operation, the AC mains drives the load through the static switch. Okay. When the power failure occurs, then this inverter is in action, or the inverter block works. But if the power failure is not occur, then this part is not perform any task. Okay. I hope you all understand the offline UPS in normal operation. Now let's see the offline UPS in power failure operation. When the power primary supply breaks, the battery stops charging and the static switch transfers the output line to the inverter side very quickly. At the same time, the inverter starts drawing the current from the battery, which is then supplied to the AC load. Okay, since it stays off when draws current from AC line during the normal operation, it is known as offline UPS. That means if the power failure occurs, that means the AC mains power failures, that means it does not supply power to the load, then in that case the charging of the battery is also stops here. Okay, that means this block is not in working, but the whatever the charge stored in the battery is in the DC form. This DC is converted into the AC in the inverter, and now the inverter drives the AC load. That means in power failure mode, the charge flows through battery, inverter, AC filter, static switch and then AC load. Okay, here the it stays off when the it draws current from the AC line during normal operation, hence it is known as offline UPS. That means this part is off here, this part is remains off in the availability of this AC mains, hence it is known as the standby UPS or offline UPS. I hope you all understand the working of offline UPS. Let's see some important points about it. The offline UPS mostly stays off in normal operation, and because of that the temperature of the components stays low. Therefore, it requires smaller heat sinks, and the components with the lower tolerance can be used, which also decreases the overall cost of the offline UPS. Since it stays off in the normal operation and does not use the battery continuously, the efficiency of the system increases. These are the advantages of the offline UPS, that it requires the smaller heat sinks and its efficiency is high, its cost is low. Okay, these are the advantages of the offline UPS. But the downside of the offline UPS, that means the disadvantage of the UPS, is that the directly supplied AC is not completely isolated from the load. Therefore, there is no protection between the load and the source, and the distortion or the fluctuations in the AC mains can damage the connected load. This is the disadvantage of the offline UPS. Now, let's see the next type of UPS, known as the line interactive UPS. The line interactive UPS is similar in construction as that of standard or standby UPS or offline UPS. The only difference between them is the line interactive consists of automatic voltage regulator along with EMI and RFI filter. That means this is the additional part in the line interactive UPS. The automatic voltage regulator removes the fluctuations in the voltage along with the suppressing surges in the voltage. That means we see that in offline UPS there is a switch which connects the AC mains or the inverter to the load. Here the switching time is 5 milliseconds, and in this time When the switch changes its position, then the large spikes or the large voltage can damage the other components of the system. Hence, to remove or to smooth these spikes in line interactive UPS, the additional part is used known as the automatic voltage regulator and the filter. Okay, this is the main difference between these two types of UPS. Now let's see the next type of UPS. What is an online UPS? The online UPS is a type of UPS that supplies power to the AC load through rectifier and inverter combo in normal operation and uses inverter to supply AC power during the power failure. Therefore, the output power supply always stays on and there is no need of switching. Hence, there is no time delay in switching between its sources. There is no interruption in case of power failure even for nanosecond. That means in online UPS there is no switch is used. Here in this diagram we can see here that there is no any type of switch is used for its operation. Let's see its operation in two modes. First one is in normal mode operation. During normal operation, it converts the AC supply from the AC mains into the DC using rectifier and charges the battery using the charge controller circuit. That means when the power is available, it is given to the rectifier which converts AC into DC. This DC is smoothened by this DC filter and it is given to the charge controller. This charge controller charges the battery. This battery supplies the inverter. That means battery has the DC supply. The inverter converts into the AC. It given to the AC filter and it drives the AC load. That means here is no switch is used. Okay, no switch is used in this case. Now at the same time the DC power from the charge battery is being converted into the AC using an inverter to supply it to the output of the AC load. I hope you all understand this function here. Let's see once again. The AC main is given to the rectifier. That means AC is converted into DC in rectifier. This DC is smoothened in this filter and it is given to the charge controller. The charge controller charges the battery. The battery has the DC supply and it is converted into the AC. That means DC to AC conversion is done with the inverter block. This AC is smoothened with AC filter and this AC is used to drive the AC load. Okay, this is the normal operation. In case of power failure, the UPS will stop drawing current from the AC mains and stop charging the battery. But the AC load will continuously draw current from the battery through the inverter. Therefore, online UPS has the zero time delay when switching its power source. It is also why known as online UPS because it stays on even during its normal operation. That means when the power cuts or power failures, then this block, that means the charging of the battery stops, but AC load drives the current or suppose supplies the current from the battery through inverter and AC filter. Okay. The important point regarding to the online UPS is that since the current drawn by the AC load is continuously flowing through its whole circuit, the temperature of the system increases. Therefore, it needs comparatively large heat sinks and the components that can withstand high temperature and can tolerate the current flow for very long duration. Due to such requirement, the cost of the online UPS increases significantly. Okay, this is it continuously draws current from the battery which quickly reduces the lifetime of the battery compared to the offline UPS. Okay, they are more inefficient because they continuously stay on even in normal operation. These all are the disadvantages of the online UPS. The disadvantage is that the temperature of the system increases, hence it requires large heat sinks due to which the cost of the entire system is increases, and due to this the lifetime of the battery is reduced because it is continuously on and it is inefficient. These are the disadvantages of online UPS. On the other hand, it offers high quality output because there is no gap during the switching between the source and supplies. It completely isolates the output from the AC mains, therefore, it helps in protection against the distortion and the fluctuation in the AC mains. These are the advantages of online UPS, that it has the high quality output and it isolates the output from the AC mains. These are the advantages of online UPS. Let's see the basic difference between online UPS and offline UPS. In online UPS, the UPS that supplies power from AC mains to the load through the rectifier and inverter combination is called as the online UPS, while the UPS that supplies the AC mains power directly to the load is known as offline UPS. Okay. It online UPS continuously draws current from the battery, while offline UPS it does not draws current from the battery during the primary source failure or the power outage. The online UPS requires a large battery charger circuit because it carries the entire load current. In offline UPS, it requires small charger circuit because it only charges the battery. The online UPS, the input supply and the load is completely isolated, while in offline UPS there is no isolation between input supply and the load. In online UPS, it has high performance output because it protects the output load from the input voltage spike and distortion, while in offline UPS its performance reduces with the input voltage distortion which is directly connected to the load. In online UPS, there is no switching between source, hence no time delays, while in offline UPS, it uses a static transfer switch to switch between its source with a time delay of 5 milliseconds. The online UPS stays on almost all times, and the offline UPS it turns on only during the power failure. In online UPS, due to its continuous on condition, it is inefficient and unreliable, while the offline UPS is more efficient and reliable because it mostly stays off. The online UPS requires large heat sinks because of high operating temperature, while the offline UPS requires smaller heat sinks because of low operating temperature due to its state mostly. The online UPS components used must have the tolerance to withstand a high temperature, while in offline UPS there is no need for the components to have high temperature tolerance. In online UPS, it is expensive than offline UPS, while the offline UPS is cheaper than the online UPS. The last point is that in online UPS, it is used for very sensitive electronics that cannot tolerate any gap between supplies, such as in hospitals, ICUs, etc. While offline UPS is used for electronic equipment that can tolerate a delay of 5 milliseconds, such as computer, etc. This is the basic difference between online and offline UPS. I hope you all understand the operation of online and offline UPS. Let's see once again. In offline UPS, the operation can be explained in the two modes, that means in normal operation and in power failure operation. While the AC mains is available, that means the power is available, the AC mains is connected with the AC load through a static transfer switch. At the same time, the AC mains is used to charge the battery through rectifier, filter and the charge controller. When the power failures, that means when the AC mains is not available, then the static switch connects the battery to the AC load. That means the battery is connected to the inverter. That means inverter converts DC into the AC, and this AC is used to drive the AC load. Here in the normal mode, this part is in the normal mode, this part is in standby condition, hence it is known as the offline UPS. Okay, while in online UPS, the operation is that in normal mode, when the AC mains is available, the AC mains is used to charge the battery, and the battery supplies the AC current to the load through the inverter block. That means there is a continuous online process. If the power failure occurs, then the battery supplies the load through the inverter. Okay, that means here the battery continuously charging and discharging. Due to this is known as the online UPS. I hope you all understand the concept of uninterruptible power supply, that means UPS. Thank you.